Yeehaw! Yeah. Oh, that's cool though. In this episode of the Mountain Bike Build Series, I'm going to start welding this bike frame together. If you've been following the series, you've seen me design this, order materials, cut them, miter them, finesse the fit. And what we have here is the front triangle loaded into my homebrew frame building fixture. And I use the frame building fixture to set the tubes with the correct relationship and distance away from each other so that they're square where they need to be square and in plane and parallel where they need to be in plane. And some people will weld out a frame in the frame fixture. And I don't know if there's anything wrong with that, but the way that I've always done it and what kind of makes sense to me is to use the frame fixture for setup, tack weld it, get welds that are holding it together in one piece, but then actually do the finish welding away from the frame fixture. And since you're on YouTube, you should definitely check out Carl Strong's YouTube channel. He doesn't have a whole lot of videos, but the ones he has are gold. And he talks a little bit there, and I've seen him talk other places about using this method where you tack it in the frame fixture, and then he'll weld it outside of the frame fixture. And I think he actually uses shims, so the frame fixture is out of alignment. And then he uses weld sequence to pull it into alignment, because when you heat it up, you know that it's going to move. And when you've made thousands of bikes like Carl has, you can actually pretty predictably control that. So I'm not a wizard of the weld sequence, but that's the way that I like to do it, is to tack it in here and then weld it outside of here. And while you're welding it, occasionally stop and check alignment so that if it needs to pull one way, you can use heat to stitch that side of the frame first. It'll kind of pinch that together and pull the frame into that sort of alignment. A lot of people like to weld in the fixture, and I think the idea there is that it holds it straight while you're welding it. And so that works for people, and I'm not going to say it's a bad way to do it. My thinking, or the argument that I've heard that makes sense to me about that, is that if you weld it in the frame fixture, there's some stress built in there as you're welding it, and that's going to stay in the frame forever. I think Carl says that in those videos where he talks about sort of alignment procedure. And so it makes sense to me to not weld it in the frame fixture, but certainly a lot of people do it with great success. So if it works for them or if it works for you, then more power to you. I'm not going to bust your balls about it. So before I can pull the welder out here and put little tack welds on the frame and pull it out of here, I need to do final cleaning on the tubes to get off any oils or anything. Anywhere that there's mill scale like this, I want to sand that back to bright, shiny metal. I need to make sure that all the miters fit really tight all the way around and that nothing is shifted and that I'm really happy with it. Wherever there's a gap, it's going to be harder to weld without burning a hole through anything. And it's also it's going to be harder to just make as strong of a good quality joint. And as a sort of amateur welder, I'm going to do everything I can to stack the deck in my favor. If I spend an extra minute or two getting a nice tight fit and it saves me a bunch of money or time fixing something later, that's great. So that's the way I'm going to go about that. Make sure everything fits tight. And then also there's, you would have seen earlier in the series where I drilled holes into wherever the tubes join. I want the gases to be able to flow through there. And there's a couple reasons for that. So one of them is back purge. If you're making a bike out of titanium or stainless steel or even steel sometimes, it's not a bad idea to flood the inside of the frame with argon gas, which is an inert gas, right? It's a good shielding gas to have on the inside of the structure, because as it gets hot on the outside, it's also getting hot on the inside, and you can pull contaminants into the weld puddle. In the case of titanium, that'll make a frame that'll fail. You'll see this scaling, and it looks like, people call it fish food, but it's like a discoloration, and it looks really bad on the inside, and that's a sign that the weld is definitely compromised. On steel, you don't really need to back purge, but it's not a bad idea. It helps you create a kind of a nicer, cleaner weld on the backside. Some people say welding on the outside goes easier. And then you have sort of the middle ground where you have really fancy alloys of steel or actually stainless steel, where you really should be using back purge. Now this is all chromoly steel. None of it is particularly fancy stuff. None of it's particularly thin. And the reason that I'm not going to back purge it is because I don't have a whole lot of argon gas on hand, and hooking up all the hoses is kind of a pain in the butt. So, thousands and, maybe hundreds of thousands or probably millions of steel bikes get TIG welded without back purge, and it's generally fine if you get a good weld in the first place. So I'm not going to worry too much about it, but it is better if I had more gas around in my bottle and I wasn't at risk of running out today, I would maybe go through the hassle of back purging this frame. So yeah, I just need to drill these holes and do the final prep to make sure everything's clean, load it back in, and then we can tack it up. So I need to add some holes to this bottom bracket shell so that the gases can flow through these tubes. The way I'm going to do that, I'm thinking is I'm going to put a mark here that spans across these, and also because this can spin, I'll do it here, whatever. That'll help me phase this up. I'm going to trace around these, which I've already sort of done. Yeah, it's kind of tricky getting it to follow all the way around. You get the idea. Just tracing around the outside. And now I'm going to pull, let's see here. I'm going to lift out the down tube. I'm going to trace around here. So now I know that I can drill a hole here and lift this guy out of here. Yeah, so I got a hole here, and then also I'll do a hole here. And so if I didn't make these marks, I would have to figure out some way of keeping track of it. I'm going to drill the holes, and then I'm going to get rid of the mill scale too, which will get rid of these Sharpie marks. And so on the very edge, I'll leave this blue mark on the very edge so I know how to phase it again. There'd be different ways to get the phasing of it right so that the holes, you wouldn't really want, I'm going to weld all along these lines basically. I don't really want a hole right here. I could probably make it work, and I don't know if it would make the the bike weaker necessarily, but I would like to be able to make a weld there, and it'll just be easier if the holes aren't overlapping. So I just use my little Sharpie marks here to lay this out. Use the digital readout to get on center in this y-axis here, and then I put the cutter close to the surface, and I just kind of swept it back and forth until it looked like I was on the apex of the tube. Looks good to me. It's not a dire location or anything. And now as I rotate the tube, I'm not going to change anything about the y-axis, but I'll just have to get centered up again. I'll put it so that the X where I want it is about on the top. This is just kind of a rough thing, not using indicators or any real measuring tools here. That looks pretty good to me. Beautiful. I gotta switch the belt on this thing, it's totally kicked. You know why they call it a delta? Because you gotta change the belt all the time. Smooth as a baby's bottom. Oh yeah. So I just got to remove mill scale from the rest of these now. So, while I was doing this joint that I'm about to weld and this joint, I also hit these because this is, another spot that once it's welded into the frame, you can't twirl the tube on here, and so you can still get it by hand with emery cloth. It's just a little bit easier while you have access to it. Additionally, I said in the earlier videos I drilled these holes for water bottle bosses with screws that protrude to the inside, and I think I will actually end up using the external only style studs that get welded on here, but either way I need this to be clean, and so yeah, just wanted to explain that. The top tube and the down tube already have like a polished finish, so I'm just gonna hit these just a little bit. I don't know that I really need to. What's probably more important for these is just cleaning them with like you know, like something to get the oils off. But while I'm doing these, I'll just hit this. So now that I got the outside all shiny metal and all the weld joint areas, so these tubes have mill scale on the inside too, and so I'm gonna hit that next. And there's different ways to do that. I'll demonstrate a couple methods. So here I have a collection of different things that I can use to clean the insides of the tubes. One of the simplest is emery cloth, and so I actually keep a roll down here. This is 80 grit, and it wouldn't be a bad idea to have 80 and 120 and maybe 220, you know, like coarse and medium and fine would be useful to have, especially if you were doing like polishing of stainless parts or like finishing of frames before paint, or if you had titanium stuff and you were trying to give it that shoe shine, you know, whatever. Anyway, but I just have 80. That usually gets me through most of what I want to do. So I want to clean the mill scale off the inside, and for instance, you can see that here. That's not bright shiny metal on the inside, and I would like to make it bright shiny metal. I think it's gonna weld a little bit nicer, and you know, for the amount of time that I'm putting into everything else on this frame, I might as well hit that. So different ways to do that. This thing is pretty cool. This is like a little flap disc thing that you can put in a drill or in a die grinder. I don't know if that's 3/16 shank, and that's the part number on it. And yeah, so I mean, this one, you just put it in. So already you can see I shined that part up a little bit. I mean, I would want to go at least a 1/4 inch back all the way around, would I think be good coverage. But there's more. There's different ways you can do that sort of thing. This is something I heard about a long time ago. Somebody was calling this a wind-up. But this is just a 1/2 inch. I think this was originally like a bolt or something, but just a 1/2 inch shaft, and you just hacksaw a slot in the end of it. Anybody can make one of these. And then you put in a piece of emery cloth, and you gotta be careful with this kind of stuff because you know, once it's got a lot of grip, so you know, you can grab your finger in it or something. You can do a longer strip, makes a larger diameter sort of drum, and then you know, you just spin it around in here. So that's pretty effective. You can also, instead of 1/2 inch, you could do like a 1/4 inch or 3/8 or whatever size in metric you want. You know, whatever you have available to you. It'll fit in the end of even like seat stays and chain stays. You can make it work to clean the insides of those, which is nice. You can get little wire brushes in small diameters, but I feel like those don't actually have enough bite to really remove mill scale. So I prefer to use something like aluminum oxide emery cloth. And then here I have the Dremel. And this has one of those sanding drums. Again, it's about 80 grit. And this baby spins real fast. And it's kind of the same idea. You know, you just kind of, you see a spot that's not really shiny. And so you can see this one here, seems like the edge of the drum kind of catches it. And it leaves more of like a thin streak. And I think what's nice about some of these other ones is it's more of a broad contact and it leaves kind of a smoother finish. So I maybe prefer those. And then, even lower tech, you have, this is a piece of stainless that I have that's 1/2 inch or like 13 millimeter in diameter. But you could get like a dowel rod, like a piece of wood, and that's a little bit softer. And then you take your emery cloth and you lay it on sort of like this. Or you could even do it with your finger, but it helps to have something else. And then you do this sort of number. So these are all just different ways to clean off the inside. And yeah, I don't know, I collected these over the years as different techniques, and they're really valuable to have at your disposal. Even I think this is probably the most expensive. I don't know if this is like $6 or $8. It's worth having one of these around. They do get plugged up pretty quick with like grime and mill scale, so they cut really good for a short period of time, and then they kind of get loaded up. But you know, not a terrible expense. They work really nice. All these work pretty well. I'm gonna say I think the wind up, this thing is probably my favorite today anyhow for this kind of stuff, because you know, you take a piece, it's however long it is, and then as it starts to get, you know, like as you have it wound up, the only part that's cutting is the last little tail of it, you know, right here. And as you do a bunch of, sanding, this stuff here will lose its ability to bite, and it'll get loaded up. You can just rip off the end of it, and then keep going. And because it's wrapped over itself a couple times, it gets a little bit squishier. Certainly like this is kind of hard and it cuts on the corners, and it's a smaller diameter, whereas this one is a larger diameter and it's a longer length and it's a little bit squishier, and this makes nicer contact, and this is working pretty well for me. So this is maybe, I'd say, start with this. It's cheap, it's easy, and it works pretty well. You can see there, that's just mill scale and crud loading up the paper, and you can just rip off that tail and you get down to some fresher stuff. So I got a little shot bottle for acetone, and sometimes I'll clean this kind of stuff with Simple Green cleaner. I don't know which one is, technically speaking, ideal or better, but they both seem to work well enough for my needs. So let's put some of this on the paper towel here. You don't want to breathe this stuff directly in. You can see I'm picking up some, just some dirt off the surface. Whew. Smells like 10 Sharpies right up your nose. So I'm grabbing a bunch of my weld rod. This is Weld Mold 880T 035, 35 thousandths of an inch, which is about 0.9 millimeters in diameter. And so this stuff comes a little bit dirty, and I'm just gonna perform the same treatment. Put a little bit of acetone on here and then scrub it down. And you'll see that you'll get a little bit of dirt off of it. I suppose with my nifty weld storage tube, this keeps it out of the elements and stuff. You could probably clean the whole shebang when you put it in here, when you get it from your supplier, and then it would probably stay pretty clean. I'm in the habit of doing a little bit at a time, which is maybe an inefficient way to do this. Let's start loading the parts into the fixture. Okay, so I can see my Sharpie mark from before, and I gotta say, this isn't that fussy. If this was like titanium or something, I'd need to be really careful not to touch it with my dirty hands. It's maybe not quite as fussy because it's steel, but I'm still going to try and keep it clean, keep my hands off of the weld zone more or less. I was lining these up with the marks I made before, and that lets me know that it's rotated to the right angular position here. So next I want to set in the seat tube. And now I had scribed lines with a caliper so that I knew where to center this, and you can't see those anymore. I had mentioned that. You can't see them once it's in there. So I need a way to measure this for center, and then I'm actually going to weld these together before I load anything else in here. So the bottom bracket shell is 90.5 millimeters. This tube diameter is 34.9 millimeters. So we take 90.5, we subtract 34.9, and then we divide that remainder by 2, and that gives us this width that we want to see on either side, which I've derived as 27.8 millimeters. I set my calipers to 27.8, and now I can just compare side to side and get it lined up. So if you study the frame fixtures that are out there, you'll see some really cool features. Jeff from Sputnik Tool has designed his, and there might be others who do this too, where there's actually like a little standoff spacer right here, and it's got interchangeable pieces that thread on, and they're used as a positive stop. So for a particular tube diameter, it goes to the center line of the tool minus half the tube diameter, and so it's just like a stop that you can slide your tube against. And if you're building a lot of tubes, or if you're building a lot of bike frames, that could save you a lot of time to just put on the right spacer and slam it up against there. Or in the past, I used to have smaller bottom bracket shells, and this standoff here had a ledge that I could push up against, and I made a spacer that was the right distance that would fit in there. And there's all different ways of doing this. you know, this is the first bike I made in like a year and a half, so like it's not a big deal to spend 1 minute with calipers there. But, you know, if you're doing it over and over again, it's really nice to have positive stops that you push stuff against, load it in, you know, tighten it, you know, do your work. So I want to do something here. I want to, when the down tube comes in, it'll sit like this, and if I don't weld any of it until after it's all together, I will never be able to put a stitch of weld down there. And so what I'm going to do is I'm going to lay this in here, I'm going to scribe a mark, and then I'm going to weld that portion, and then I'll put this tube on, and then I'll close up the rest of it. So so I'm going to grab a little scraper and scribe some marks there. So against the, you know, the grain of the sanding is like this, so this will actually kind of show up half decent. Do that on both sides. And I did this before with Sharpie, but then, you know, you got to clean off the Sharpie to get it ready for welding. So now I can do a stitch of weld that goes from like about here to about there. I can cover almost all of that, and then that weld won't get in the way. If I were to weld all the way around this, then I would have to notch out this corner, which is another way to do it. Some people do that. You can notch out the corner here to create clearance. I'm not going to do that. I'm just going to weld most of that little inside stitch and maybe some tacks on the back. And then once that's together, then I'll move on with assembling the rest of it. I don't know why, but they ship this stuff with a little bit of green paint on the one end, and it's maybe not that big of a deal in terms of weld contamination, but I certainly don't want to put that in my welds. So while I'm here, I'm just going to snip every one of these into the trash can. I don't really weld that much these days, and you know, it's probably the last time we recorded welding related videos was the last time I welded anything. So I did some practice welds, and this was the first one that I did. I didn't spend that much time, you know, these parts are a little bit rusty, so I cleaned off the surface rust and I just welded them up. So I burned through there and there. Now the fit up wasn't perfect, but I was just trying to get some arc time. The second one, not really any different, but I managed to not burn through anywhere. It's looking a little bit better. I feel like I'm picking up my rhythm again. And then this one is a little bit harder. You know, the tighter angle is a little bit harder to get good penetration, and it's not perfect, but it's a good warm up. I think that goes a long way toward helping me, you know, get in the zone to do better work. I really hope I don't burn through these tubes. So I'm gonna get 4 tacks on this. I'm gonna do one, you know, sort of at this angle, one at this angle, you know, all the way in the 4 corners, sort of. I don't know if that's ideal. That's what I'm gonna do. And then once I do those 4, then I'm gonna stitch that section up front here that we talked about, and then maybe I'll just leave a little gap here and I'll actually weld this whole thing out. I'm not sure yet, but anyway, gonna do the tacks and get into it. And so what I'm always thinking about when I'm welding stuff is that this is heavier wall thickness on the bottom bracket shell, and when I put heat here, it can dissipate this direction and this direction on that tube. You know, if I'm coming in right here with some heat, that heat in this tube can dissipate this way and it can dissipate this way. And at the end of this tube, when I put heat in here, it can dissipate this way, and that's it. So like when I'm thinking about which one do I want to heat up more, where do I want to put the heat? You know, this is a heat gun, you're aiming the heat. I want to bias it toward this bottom bracket shell. This I know can absorb a lot more heat. This is the one that is going to burn through if one of them is going to burn a hole. And so I'm just keeping that in mind as I do these tacks to try and keep from blowing a hole in this this seat tube. I'm going to bias most of the heat into the bottom bracket. So you can see my torch angle here. It's something like that. It's more toward the bottom bracket shell. You know, if I did a torch angle like this, I would just burn a hole in this tube. So I'm aiming it down toward the bottom bracket shell. So some people would do fusion tacks for this sort of thing, and some people would do filler tacks. A fusion tack is where you just heat up the 2 materials and melt them together, and they kind of stick. And a filler tack is where you add filler. So a filler tack is generally going to be stronger because you have like a bigger cross section, there's more meat to it. The filler tack, where it's smaller, is the fusion tack is maybe going to be nicer to then weld over later. So if I'm just tacking it together to get it so that it holds itself, and then I'm going to weld over later, and I want to have a nice smooth bead, the smaller my tack is, the easier it is to make it look really smooth all the way around. And so I think that's sort of the trade-off there. And for me, I don't want to worry about it like snapping free when I get it out of the fixture, which can happen sometimes. So I'm just doing a little bit of filler, no big deal. But you know, that's something you can think about for yourself in your own process. Whatever you get used to will probably work fine. So I'm gonna work on doing this stitch now that will get covered up by the down tube later. It's not terrible. It'll never be seen again, you know, hopefully it never gets broken open or anything. Part of the reason I wanted to do full tacks and not fusion tacks here is because when I do this whole stitch here, if I just had little tiny fusion tacks in the back side, there's a lot of contraction from welding happening on the front side, you know, doing like a whole quarter of the circumference of that weld there. I feel like that has a pretty strong likelihood of actually snapping those little tacks. I didn't want to deal with that, so you know, I did heavier tacks. So I could have done very light fusion tacks on the front, heavier filler tacks on the back, and then the filler pass on the front, whatever. So now we put in the down tube, and you can see how it closes off, you know. So this still fits where it should. I didn't weld too far. If I did, I'd just grind off those corners a little bit, no big squeal. You know, there's just a little bit of wiggle. It's kind of self-fixturing, but it's not perfect, and so I'm just gonna make sure when I'm tacking it that I kinda, you know, just pinch it in the right direction so that it seals up nice. And so if you look here at the tube profile, if I come in here with my tungsten and I heat up, I got a lot better chance of not burning a big hole through it than if I come here. Because if I come here, this really wants to burn through. It's like not connected to anything. The heat goes, if you're not totally careful, the heat comes into this tube and just melts it back before you can get your puddle established. And so what I want to do is I want to kind of come at it, I want to kind of wrap around. Like as I have a weld puddle going, I can kind of watch it as I move, and I feel like I'm going to have more control if I bring the weld around over this tip than if I just come right in here with a tack. I feel like there's a high likelihood I would just burn this away. I might do that anyhow, but I'm trying not to. And so I don't know if that logic makes sense, but you know, wherever you have like a thin tang or something coming up against like a, you know, a solid piece like this big heavy shell, this is going to absorb a lot of heat before it wants to melt away. I don't need to worry about that unless I really fall asleep at the wheel. But this one wants to melt away and keyhole out, burn through. And so I need to be very careful with these little points like here and also back there. Those ones are going to have the same sort of thing. So I need to be careful with how I approach those. I'm not an expert at this, but I think if I start out here and I work my way toward it, I think I'm going to have a little better chance of making it work, because as you go, where it's connected, like the weld bead that you lay down, that I think helps diffuse some of the heat and sink some of the heat. It can conduct heat into that weld behind where you were. I don't know if that makes sense, but in my head it makes sense, so that's how I'm going to approach this. So I'm going to lay down a tack right here, and you know, again, my torch angle is mostly pointed toward the bottom bracket and less toward the down tube because this can absorb a lot more heat. And I'm going to tack here and here, and I'm going to put some tacks up on the head tube, I think, and then I'm going to start welding this out. So I've rotated things, and I want to hold this down tube in place on the head tube, and you know, similar to my considerations at the bottom bracket shell, this area is relatively safer to light up on and make tacks. I'm a little bit less likely to blow a hole in this down tube, but if I come in here right on the side, on like the ears of the miter, that's where it's more sensitive to heat input. You know, this really can absorb a lot of heat, this really can't. It's just like kind of a tip extending out there, and it's just almost like laying flat on top like a lap joint. And so I'm gonna put my tacks, I think, like, you know, quarters around here, you know. When I made this frame fixture in the frame welding stand, I wanted it to be height adjustable because I sort of knew that if you're a really good welder, you can weld in any weird position and you're awesome. But if you kind of suck at welding, or if you're okay at welding, you want to stack the deck in your favor. And like getting comfortable is really key. And so for me, I think this would be easier if I could get it at whatever height I wanted. I'm really glad I can rotate it. Some frame fixture stands actually do a tilt also, which it'd be really nice to kind of tilt this out toward me. And so, you know, something to think about if you're building your own tools or if you're buying a stand or something is like being able to get this, you know, just the right way is really going to help you be comfortable and focus versus being contorted. And, you know, I think frame builders tend to be kind of spoiled because you look at welders in other industries and they're like, you know, up inside some crawl space and they're doing something and like, God, you know, that would be terrible. You know, inside of a boiler or something. Underwater welders, man, it's a whole nightmare. So this isn't too bad, but you know, you can stack the deck in your favor by getting comfortable first. So the down tube is in. There's just like little moments that are kind of exciting to like step back and look at. I mean, this is coming together, so that's pretty cool. I could put some sort of tack. You know, I have tacks on the bottom side. I could put some tacks up here, but I think before I pull it out, I'm gonna get 4 tacks on either end of the top tube, and it should sort of hold itself together. I'm gonna try that. These moments, I think, are really exciting. You know, what we loaded in here just recently was discrete, separate tubes, and now they are a unified body, and I just love these moments where you pull it out of the fixture. So we're going to start welding it, and you know, now it's held together. I don't need the fixture for those steps. Yeehaw! Yeah. Oh, that's cool though. I get excited about this. You know, this is, I think, the 17th bike I've ever built, and it still gets me real excited. These moments, you know, where you pull it out of the frame fixture, and you know, it's one piece now. That, you know, you wouldn't ride it. It's not strong enough to ride, but it's, you know, it's held together fairly well. It's kind of cool. You look inside of the tubes, you can see a little heat register mark from the different tacks. You know, those actually look pretty uniform. You know, that's one way you can gauge, you know, how much heat you're putting into each zone, and you know, the penetration that you get is if it looks kind of consistent. Here you can see that longer stitch that we did. But anyway, it's just, you know, it's turning into a thing. Jigga, 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 jigga. It's pretty cool. I'm stoked on it. And now we get to start welding it out.